of that diamond. As soon as it goes outside that diamond, that's where the crew would actually tell it to take a step back.
Okay.
Meaning go further away while we figure out why you're not in the right place.
Why you're not where you're supposed to be.
Exactly.
Station Houston on 2, Cygnus and ISS are configured for approach inside the keep out sphere. Expect departure shortly.
Okay, copy that, Rick.
Koichi, we had a little ratty comm. We were pointing to an array.
Okay, yeah, copy that, Ricky. Thanks.
Station Houston on 2, Cygnus has resumed approach to 30 meters. Your go for HCP command checkout. Step 3 and 1.102.
Okay, that copy the go for step 3 of 1.102.
So again, Cygnus now resuming its approach. It is now at 242 meters away from the station and closing in. The next major hold point is going to be at 30 meters. And that is where it will stay until it proceeds on up to about 10 meters. And the 10-meter mark is where actually Cygnus will be captured by the crew. Again, this morning, Mike Hopkins is going to be using the arm to capture this vehicle. Koichi Wakata will be backing him up. And then later this morning, whenever it's time to install it, Koichi Wakata himself will be doing the installation with Rick Stracchio backing him up and also doing the operations on the common berthing mechanism, which that is the actual device on the station that mates the station itself with these visiting vehicles.
Houston Station on 2 in step 3, we verified the hold arm LED is flashing and the hold command is armed.
Copy, we're looking at it. Station Houston on 2, the hold arm is confirmed. Your go for disarm command, that's step 4 and 1.102.
Okay, copy that. Go for step 4 for disarming hold.
So, Josh, what they just did was basically confirm that the crew can, using that hardware control panel, that sort of control box, remote control, making sure that they can talk to the Cygnus. And that's to make sure that if they should have to request that it goes away, that their command link is secure.
Okay, so it's just a check of the systems.
Exactly, and it went quite well.
Houston Station on 2 in step 4, hold command is disarmed.
HCP command checkout is confirmed. Successful. Your go for approach monitoring from 250 meters. That's step 5 and 1.102. And be aware that Cygnus is within 200 meters, and you have a go to issue an abort command in case of there's a corridor violation during LOS.
Okay, Ricky, copy that. Go for step 5 and go for pushing the abort button in case of crew abort corridor violation per the cue card.
Good readback.
So, Josh, some of these things that you're hearing people say, I think we're used to having the communication between Houston and the station be a little bit more casual. And yet you're hearing kind of formal statements. You are now go for this. We see you here. Go for step 5. It's for a couple of reasons. One is that during this kind of operational time when everything's going well, you've got lots of time, but when it's not, you want to have really sort of short, very succinct, very understood commands. But the other perspective is that there's the space station and this vehicle just a few football fields away, right? But then down here on the ground, there are a series of 3 control centers. There's mission control here in Houston. There's mission control in Dulles, Virginia, for the Orbital Sciences Company. And then there is mission control in Tsukuba, Japan.
There's Orbital right now.
Here's Orbital, and I love these shirts. This is their team shirts for Orb 1. and I've been to this control center, and it's neat. I don't know, any of these control centers, when you walk in and it's all quiet and you think nothing's going on, but then you put on a headset and you realize how much folks are doing. So I started talking about the 3rd control center in Japan because the Japanese actually own that box that we use to control Cygnus, that communications link, and they also own the link where the Cygnus is telling the space station, like the computers in the space station, where it thinks it is.
Where it is, right.
So between those 3 control centers, there is a whole ballet going on, and that's what Josh and I are listening to on the flight loop here. Is Flight Director Brian Smith is talking to all of those, making sure all 3 of those places are in sync, and basically it's easier for everybody if we're using a little bit of a script because they know exactly what to hear, what to listen for.
And they've simmed this a lot. They've run through simulations, I mean, over and over and over again together, to kind of figure out the choreography of this. So
that's exactly right.
And Ricky, the difference VV shows 1.7 RPOP.
Good information. Thanks, Koichi.
So 49 minutes away from what should be the capture of Cygnus. The vehicle is now 151 meters away from the station and closing in at about 0.2 meters per second.
So the crew is actually working 2 procedures here. One is a card that basically talks about, okay, so what should that Cygnus look like when I'm looking at the control panel? What lights are activated? Which commands are at my disposal? Right now they've got hold. Or they just exercise the hold command, but as they get closer in, they're going to make sure and confirm that they've got the retreat command available, and so they've got those things on the rendezvous procedure. But then there's a robotics procedure, and what they'll be doing now as this gets closer and closer is together looking at these procedures, going, okay, so Mike, you're going to do this, Koichi, you're going to do this, and even though they actually both know exactly what they're going to do, they're going to review it so that it's really just like clockwork.
Secondhand, yeah.
Hey, so Josh, I want to point somebody out here. In the back of the room, you see the guy standing there in the blue shirt?
Yeah.
And so that is Ray Biginus, and he is the Visiting Vehicle Officer.
The VVO.
The VVO. And Ray has actually been the VVO for this mission, the Orb-1 mission, which is the second mission of Orbital Science at Cygnus. And he was also the lead for the demo mission. And that means that he has spent really a long time with the Cygnus team, with the NASA team, knowing exactly what this vehicle can do. And so in terms of the Cygnus approaching, where it is it got all the right, it has like a radar system, almost like a radar gun like a policeman would use. And it's trying, and it uses that to look at the space station and say, where am I? Where am I? It's got several of those. So Ray is looking at all of its systems in that way. He's in charge of basically the meeting, the rendezvous. And I don't know, it's just really neat. I know how much heart this whole team has put into this, and I'm not sure that's something that's clear to the general public, is that the folks in this room that look like they're not talking to each other have been working together really a long time, and they've been working with their counterparts at the Dulles Control Center and in Scuba, Japan. And what's interesting to me is basically how we can work without even meeting each other or seeing each other, and at the same time the importance of actually meeting each other and seeing each other, so that we really understand each other, know a little bit about each other's families, so that when things are tough, you really know how to work together.
Well, we don't fly shuttles anymore, and that position used to be very busy even during the shuttle era, but now with Cygnus and Dragon and Progress and Soyuzes and ATVs and HTVs, I mean, that position gets quite a bit of business in terms of just helping us kind of figure out all these vehicles coming up. I mean, there's a lot of kind of air traffic control that needs to be done, and they sort of help out with that.
That's exactly right. And we got a view from the cupola, I think, right here.
A little dark.
It's dark up there, but it is dark up there. You can see they've got a headlight on. And actually, it's nice to have it dark in a way because you can really see the screens pretty well. And they've got flashlights there to look at their procedures, but they will be capturing in the light for the Cygnus. And the reason for that is, if you think of the space station being up on the top, and the Cygnus is going to be under it, and so the robotic arm is reaching out under it, the geometry of where the Cygnus approaches is such that the arm is always going to shadow it. And we think of maybe needing a headlight to be able to see the vehicle itself, but really just the general lights of the station are enough to usually light the target. And remember I talked about how we have the end effector that's actually going to grab the grapple pin on the Cygnus. Well, right above that is a little target, and the camera on top of the end effector is looking at the target. So we're seeing a camera view, or we will. And like right now, it's in the bottom right-hand corner of your picture, and you don't see anything because we don't see the target yet. But usually the lights of the station are enough to light that target. In the case of the Cygnus, the geometry is such that when it is dark out, it is too dark to see that target. So we'll be captured in the daytime.
Almost 100 meters away now, and continuing to close in.
So something the crew is watching again is down in that bottom right-hand corner. There's the diamond. There's a little dot in the middle, and that's exactly where we want the dot. If the dot was to wander outside of that box, but you can see it's real steady, then that's when they'd be, talking to the ground. Nothing has to happen very fast, and I'd say that's one of the things that we work at remembering, is that even when something doesn't look right, we probably have more time than we think to work the problem. We have time to call Houston and to get the experts from Orbital and from Japan looking at it. And now you can see that there's a model of the space station up on the top, and it's like a tractor beam. And you see those little dots there? You see the Cygnus, and it's beginning to really look like, a little round cylinder with wings. Those wings are actually the solar arrays. And those dots represent where the Cygnus is going to be in, I believe they're 20-second dots. They might be 1-minute dots. I'm not sure, but basically, let's say they're 1-minute dots. The first dot means if we do nothing, the Cygnus is going to be at that first dot in a minute. And if we do nothing, it'll be at the second dot in 2 minutes, and on and on. And you can see that if we lost all communication with the Cygnus, it would actually go away from the space station.
By design.
And that is by design, so that we are in a, it's not sort of cruising in without any way to stop it, so to speak.